All right, everybody, let's take a look at the bouncing ball assignments everybody turned in. These are the ones that I've currently got downloaded, which were up in the Google Drive folder, so I'm going to go through them one at a time, take a look at them. I've also discovered, let me hide this for just a moment, that there's a grease pencil feature that's in Maya that I just never use because it doesn't seem to be available in any menu, but there's a button for it in the viewport. And I just wanted to show you guys that it exists because it's kind of neat. It's this tiny little button right here under the word lighting. And what it does is it allows you to draw on the screen, but you do have to show grease pencil. There it is. It allows you to draw right on the screen and erase. And it keeps those keyframes down on the timeline as well. So you can use it for animation planning if you want to. But you can
Where was that
also,
again?
so it's this little button right here under lighting, right there.
Oh, okay.
Yep. And so you can use it for animation planning if you want to. Only just really started using it. In fact, I looked at a video for how to use it, and the guy said, I don't know why more people don't use it, but it's this tiny little button right here, and there's no other menu for it. So I'm like, that's why more people don't use it, dude, because it's hidden. Nobody knows where it is. But you can make these frames visible on neighboring frames, so you could do traditional animation with it if you really wanted to. Or you can just write yourself notes. If you move your window, though, it just sticks right on your viewport. So do be aware of that. You can delete them the same way that you delete traditional keyframes, and then you can just close this window. So I might use that to do some notes on top of the animation that we view, or I might not, depending on what I need to say. But I just wanted to show you guys that that feature is available because it's kind of cool. All right, so this is Jesse's animation. I don't think he's in the chat. Nope, we got only a few people in the chat. So I'm going to go ahead and take a look, and then we'll make some comment on it. That looks very decent. Cool. All right, so let's take a look at the graph editor. So NURBS curve showing, grab that, and I can put the graph editor up here, kind of get it out of the way. Let's shrink it just a little bit more. All right. So yeah, it looks like translate Y. Those look like curated lines that have nice arcs, bounces in and out. Obviously broke the tangent handles to be able to do that properly, so that's good. Very nice on translate X. Got a very slow deceleration all the way to the end. Do we come to a stop? Yeah, we do actually come to a stop. So one little note about the stop is that it's a little bit sudden. It sort of looks like it bonks into a wall. Boink, right there. If we're meant to just not see that and it's just going off screen, then it's fine as is. But if we're meant to actually look at it, then you oftentimes need a little bit of rock back when you stop, and you need to coordinate the spinning and the movement very, very carefully to get a convincing roll to a halt. So it will sort of teeter back and forth a couple times, or at least get to an extreme and then roll back a half an inch or a quarter of an inch or something like that, and then stop. So just a note on that in case that was a desired effect. Let's see about squash and stretch. It looks like we've got it. Using all the controllers correctly, by the way, spin and placement and squash and stretch, it looks like. So let's get squash and stretch. That looks at a glance to be correct. So we've got stretching coming into the impact, squash, stretch going out of the impact, and then returning and doing it again. Yep. And it was pretty subtle on the first viewing, which is good. We don't want it to be too obvious, but it looks appropriate. So yeah, I'd say everything seems to be working out just fine. I don't think anything really needs to be changed on this. Can you guys guess what kind of ball they were looking at? Does it look familiar? I'm trying to see if there's a planning chart. There's no planning chart in Google Drive. Does this look like a kind of real world ball that you could identify?
Maybe a basketball with the dampening of the bounce.
Maybe. Yeah, a basketball maybe that's not fully pumped up and not on a basketball court. Could be a rubber ball on something softer than like a wood floor or a hard concrete floor. Could be a tennis ball that's a little bit flat. So that's an important thing to note, is that we are doing this from real life reference. And if people can identify the kind of ball that you animated without ever even being told, then you really did a good job. If they can't, then probably the principles and the animation that you did are fine. It's just that there's something missing that would make it unmistakably a real world recognizable object. And that's sort of a higher end goal. So very good. Good job, Jesse. Let's take a look at Yang's. All right. Cool. So Yang's has a much higher return ratio and starts bouncing and rolling for longer. Cool. So before I even scrutinize it, what do you guys think? What kind of ball is this likely to be?
One of those bouncy balls.
I think so. It looks heavy enough. Um, what makes it not look like a ping pong ball? Because a ping pong ball could do that too, right? Kind of an
Yeah, that's
interesting
a good point.
question, right? Yeah.
I
Yeah?
I think like the length of how it bounces. That's what I'm thinking.
Like
Like
the
how
travel.
yeah, that's what I'm thinking is what's kind of making it not a ping pong ball.
And what would a ping pong ball do different?
I feel like it would go a lot a lot more random in
Yeah.
that.
Yeah, I agree with you. I think that you're right. That a heavier ball has more inertia and will just keep on going or slowing down. But a ping pong ball has like none. It's so light. So any imperfection in the floor will bounce it into a new direction. Any amount of wind resistance will stop its travel. A ping pong ball will bounce, 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 bounce forever, but it'll sort of meander around in circles and in curving lines in the same spot. It won't keep a direction for so long. So yeah, that's a good observation. So Yang, are we right, or we're guessing bouncy ball, super ball?
Is the rubber ball from the videos that you put on the
Oh, the
drive?
the blue one.
Yeah, it's the first video in the is the first ball that you show in the reference.
Yeah, the blue rubber ball. Okay,
Yes,
I would
that one.
say that it's still fairly believable, but it feels like the super ball because of how long it continues bouncing and how fast those bounces are. It may be that if I'm remembering the reference, you're just moving it a little too high up in the air for too long. That if we took your Y graph, oh, okay, I'll say this: the return ratio for the blue ball was a lot shorter than that. So you've got like a 90% return, right? I think that the blue ball returned like 2/3, something like here, and then we would have this diminish a lot faster. That's my guess. So what I'm going to do really quick is just scale. You know what I would need to do? I would need to like curve the whole thing. It would take me longer because when I move this, the tangent handles are going to go all weird every time I do this. I'd have to like scale each individual one like that, which I'm just not going to do. But I think it's that when we get down here, the bounces are still pretty high, and so it feels a little bit more like a super ball or a ping pong ball, where I would kind of expect it to be dribbling like at this height for a long time, but not this height. Does that make sense?
Not really. Can you explain that again? Sorry.
See how high off the ground it's getting in this region?
Uh-huh.
I would expect that to maintain itself for this long, from here until the end. Dribble, 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 but it's still bouncing so high that it feels like a rubber super ball or a ping pong ball. And so what I'm identifying in the graph editor is how little the height is changing from bounce to bounce as one of those things that makes it not look like a rubber ball. You get that idea?
Um, yeah, yeah, okay.
So I would say that it would need to drop in height a lot sooner and then just maintain the little dribbles for a lot longer. So it would be a scooping line across all the tops rather than a straight line. Okay?
Okay.
Cool. And I'm not saying it's wrong necessarily, it's just something that would probably help the recognition and appearance of the ball. it looks like all of those arcs are defined correctly. They've got nice rounded tops, nice sharps on the bottom. Let's take a look at the X travel. The X travel looks like it's not really smoothly slowing down. It changes speed right here. What looks like linear. Yeah, it is linear. So just make sure that's set to either default or some unified tangent like this, and then you adjust it so that you've got a smooth, oh, the handles are also broken. So let's unify those. They don't need to be broken. So it's got a smooth travel, a smooth kind of slowdown. Did you want it to come to a stop, or is it just off screen?
I just wanted to keep rolling off screen.
Okay, then we'll just not worry about that part up there. Do we have squash and stretch? No squash and stretch?
No, because I thought we were doing like from real life, and I didn't see like that is
Well,
the
we
squash
are.
and stretch for like for cartoony stuff.
Well, you're right. We are doing it from real life, but squash and stretch is often something that simulates lens effects. So, like blur. And I do talk about that in the lecture a little bit, that although stretch is a completely made up thing as far as the physical nature of the ball, we might stretch it to give it an appearance of being blurred in the camera frame. And just because we're doing something realistic doesn't mean that we completely copy reality down to the last atom. We are still interpreting what we're seeing and trying to represent it in a way that is as recognizable or more than a photograph of the thing would be. So it's sort of caricature in a way. Since this is the blue rubber ball, I would say a little bit of squash and stretch, at least on the first few bounces, would probably be appropriate. And then we'd probably abandon it by the time we got halfway through, because there's no way that we're going to see any squash and stretch at that point. But given how fast this is traveling, we probably need to see a little bit of that.
Okay.
Okay? Even in realistic things. One other thing I noticed is that there's a little bit of a trouble keeping my eye on the ball as it hits the bounces. I see it when it strikes the ground. I see it as it approaches, but then it sort of flickers as it bounces off the surface itself. And I think it's because one thing that you're not doing is taking complete control over the spacing of the ball as it's getting near the ground. So this frame is the hit. This is the frame right before the hit, but there's no keyframes there, right? So it's completely being controlled by the arc in the graph editor. That is what I told you guys to do, but you can do extra. And the same thing's true coming out. Like, so here's the hit, here's the frame right as it left the ground, and there's no keyframe until we hit the apex. So you can, on that very next frame, put a keyframe in and adjust how high off the ground it is manually. And it will mess up the graph. So let's go take a look at it. It'll mess up the graph a little bit, but it can help us to view the animation a little bit better. You'll see that these tangent handles will suddenly look really weird. So what I'm going to do is I'm going to just put a keyframe on translate Y on this side a little higher and on this side a little bit lower, and then fix the resulting handles that I get from that. So I'm just going to set it to flat and then readjust it so that we've got a nice arc. And then over here, set this one to flat and readjust it so I've got a nice arc. And then over in here, we no longer need this to do anything because we're taking control of it. So I'll just set it to linear because it's not going to matter. So the difference then is that here, we're going to get a slightly different position as it comes into and out of that bounce, which means we'll distinctly see the ball 3 times instead of just 2. Sometimes if you don't do this, so let's go to the next one, you'll have equal heights there, and it'll sort of just look like a flicker when we view the animation, which makes it a bit harder to keep your eye on it. You see as I go faster, it sort of just looks like a flickering, whereas over here now, we're going to see 3 different distinct positions, and it makes it a little easier to see the ball as it travels in and out. It's a very subtle effect. It was not a part of the homework, but I just wanted to at least mention it one time because you can take control over the position of the objects whenever you want for whatever reason. And this is one of those extra performance, perfectionist kind of things that we could do. Does that kind of make sense?
Yeah. Okay.
And I know this is a weird idea, but it's very, very often done that you have to do something like this that kind of breaks the perfection of the graph in order to get a better visual effect. Okay. Cool. All right. Yeah, I don't see anything wrong with this at all. I think that you did a really good job. So there we go. Any questions or comments from you?
No, I think I got it. What you were saying.
Cool. All right. Very good. Thank you. Let's go ahead and take a look at the next one. We've got Miguel. How's it going?
Not bad.
Cool.
I was working in inches, so
Okay.
I'm a little worried about how it's gonna look.
Inches. So what was a Maya unit? Whoa. Okay. So did you
Yeah.
turn one Maya unit into 1 inch?
Yeah.
Okay. How big was the ball?
I am not entirely sure.
Because this ball is 1 Maya unit, which would be 1 inch.
Yeah, so I guess it would have been an inch.
What? But was it?
I didn't check the scale of it before doing anything.
Okay,
I
let's
forgot
just play it.
because I was working in inches before and I forgot to switch it.
It seems reasonable enough. Let's see. What do people think this ball is? And should we be looking at the end roll, or should we be cutting that off?
Where it like stops and it keeps spinning was where I figured it would cut out. I was trying to
Okay.
frame it.
So we'll pretend we can't see that. There. Does this look like any kind of recognizable ball to you guys?
Bowling ball-ish.
Wow, what a bounce that bowling ball. I mean, that's possible.
Yeah.
But that,
Isn't it like a
Pretty
baseball?
high.
yeah, but you're kind of viewing it as something stiffer rather than something squishier.
Yeah, mad heavy.
Is it a medicine ball? Or no, wait, no.
Medicine
it a
balls just go
marble?
plonk.
That's for yeah, exactly. I was like, wait a minute.
I feel
Is that a
like
marble?
yeah, maybe. How about a softball or a baseball on a hard surface?
That might make sense with why it's continuously rolling.
Yeah, and again, so what we're looking at is it doesn't lose hardly any speed going sideways, even though it loses a lot of height per bounce. So we're thinking something that has mass but not bounciness, and so that as like bowling ball, softball, a marble, all of those things kind of make sense, although our sizes are like wildly varying. So Miguel, what kind of ball was it that you were observing?
I think it's a slightly flattened tennis ball on hardwood.
Slightly flattened on hardwood. I could see that. I think we would still want some appreciable slowdown in the sideways motion, unless we were on a slope or something. And then it would make sense that it maintains its speed, or if it had some spin when it was dropped. So let's take a look at the graphs. How come I don't see any controllers? That's weird. Okay, so I've got oh, I was just in the wrong menu because I'm stupid. All right, so let's take a look at the graph and see what we've got. So the bouncing looks decent. I think you've got the right idea here. They're a little bit I don't know how to describe the difference, but they're a little molehill shaped as opposed to rainbow bridge shaped. I'll show you the difference here. If I were to, can I move it? Oh, you don't have weighted tangents. I think, is that the edge? Make sure. Yeah, I think your tangents are unweighted. So here, free tangent length, it says that it's on. Okay, can I just lock them? Okay, all of the curves are non-weighted. So one of the setup steps that I did was to make the curves weighted tangents, and it was so that we could drag these handles out further. So without that, you're not able to do one of the things that I demonstrated in the video. Did you find that that was true?
Yeah, I tried scaling them out a little bit and I couldn't get it to work.
Okay, so the answer is down here. Weighted or non-weighted tangents. When you find that you can't, you don't have to set it as a global setting, but I always do just because I want it to be available. You switch it to weighted, and now those handles will be able to be dragged outward like this, wherever you want really, except for past vertical because that's impossible. Okay, so now instead of this shape, I'm looking for that kind of shape, like a slightly more rounded shape. And if I move these tangent handles out just a little bit, I probably went no, I was going to say maybe I went too far, but I think that's the right shape. So it's the difference between this sort of rainbow arc and this molehill arc, which is rounder on the top and flatter on the sides. That'll create a more physically satisfying bounce. So let's see that first one. So you kind of can see on the second one, it appears to sort of travel linearly for a little bit up and down, whereas on this one now it's always changing its spacing forever. Does that make sense?
Yeah, I get you.
So I could do a different visualization if you want to see the difference. We can make this object ghost itself. You want to see that?
Sure.
Okay, so if we go to animation, visualize, ghost selected. Let me make sure the option box is set. Yeah, ghost the geometry. That'll be fine. Okay, so let's hit apply. Oh, you know what? I should grab the geometry instead of the controller. So, there. All right, so now you'll be able to see, let me move this out of the way. You'll be able to see that the spacing on this first drop, right, it gets wider and wider and wider. And on this bounce now, it goes from wide to smaller, 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 wider, 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 wider. But on this one, the spacing is very even on this first part of this bounce. Then it gets smaller, then it gets wider, and then it gets even again. That's the difference between those two graph shapes. So we're losing a bit of the change in spacing when we don't have a perfect arc shape. And when we do, we get perfect spacing getting bigger and bigger the entire way. So you can see even those last few frames, this one's clearly the biggest spacing, then slightly smaller, slightly smaller, slightly smaller, on and on and on. So that's the difference between, where'd it go? Oh, and now I'm grabbing the geometry. Let's see. There.
Yeah, I feel like that's a little bit floaty at the peaks, but the impacts are definitely a lot better.
It is probably a little bit, because that's what I was debating is, did I make this too wide, right? And so if I thin that just a tiny bit, that's probably going to be better. It's still sort of a round shape rather than a torpedo, but I'm not lingering as much. The more you do this, the more floaty at the peaks it will be. But the idea is to just get a round shape rather than a flat portion of it. We could alter this one without even widening the top. Just move this tangent handle away from that line a little bit, like this. And so we don't even need to stretch the center. This will have much the same effect as what I did. So now, still got that good spacing. This one's spacing is much improved now. And now if I play it back, it shouldn't feel as floaty.
Wait, how did you get that effect where it's where there's more balls? What the heck happened?
Ghosting. So I did visualize. This is an animation subset menu. Visualize, ghost selected, but you have to grab the geometry if you want it to work correctly. So I unreferenced the geometry layer so I could actually touch the ball surface, and then applied the ghosting to it, and then you can just re-reference that so we can't select it anymore. Now we can see frames before and after the current time. It's a nice visualization technique. I try not to have students use it too much at first, because we should be planning and getting to know the graph editor, but it can be really great for figuring out what something is doing through space. Cool. Yeah, and other than that, I mean, everything else looks completely fine. Do we have squash and stretch on the ball or none?
No, I was thinking the same thing as Yang.
Okay. When it's moving that far through space, definitely we're going to want some squash and stretch. It would have to be a very, very dense, hard material for us not to include it. If it's anything even semi-pliable, then you're going to want to apply that. The idea is, if you held it in your hand and you squeezed and you could make it flex, probably in animation it should flex that amount. So a tennis ball, we could give it like a good 10 to 20% deformation. And so we'd probably want to stick within that if we were going realistic. If we were going cartoony, then of course we could just crank that way up. But really, the maximum amount of stretch that I've got available on this rig at all is pretty understated compared to what a cartoon would do. So that's still within the realm of possibility, at least for like a fastball or something. Okay. But I understand, it's at first we're looking at footage and we say like, well, I don't think it squashes and stretches at all, but it did motion blur, right? When you're freezing on
Yeah,
those
totally.
images, that's the same sort of thing. Okay, so for animation, we always want to exaggerate, caricature, and interpret a little bit. Otherwise, we might as well simulate it.
Yeah, I failed to understand that it was like a visual thing, not necessarily
Well, and that's it's
trying
a
to be convincing.
yeah, and it's a valid question. Like, why wouldn't we just simulate this? Why wouldn't we just set gravity and a ground plane and an amount of elasticity and then just hit play? We could. And oftentimes, your simulation is going to be superior in many ways to an approximation of something that you'd see on footage. The reason that we don't is that there's two different distinct jobs. One is simulation and effects, and the other is animation. The animation one is about the caricature, interpreting it, giving it life, giving it a feeling of reality without actually copying reality necessarily. Unfortunately, we have to copy reality to get our feet solidly planted on the ground as animators, and so it's very confusing at first. But yeah, you didn't do anything wrong. It was a choice, so that's good. But try to push it a little beyond what's real and get to the essence of what makes that thing feel like that thing, and you'll be in really good shape with animation. Cool.
Got it. Thank you.
Thank you. Very good. All right, let's see. We've got Elias. All right, so we got this top view. It's probably the last one he was working in. Let's go back to perspective here and see what we've got. Okay. So this one appears to lose a lot of power very quickly. And there's a little hiccup there at the top of that arc, which we'll address in a second. What do you guys think? What kind of ball?
And it's something that loses energy real quickly.
So squishier or softer or very stiff without the capability to bounce. It also loses a lot of rolling speed. I think the difference between something like a bowling ball or a golf ball and something that's very squishy is how long does it keep rolling, because that's a second type of friction that can be applied. I'm not really sure, but I would say like deflated soccer ball, deflated basketball, really deflated tennis ball, maybe something like that. Let's take a look at the details because I see something already. Yeah, there it is. So even just opening the graph editor, I can see it just glaring out at me. This one, that bounce felt sharp. So it was the first time it hits the ground, and then it rises up. Point. It seems like it hits a second wall up there in the air. So it's just too sharp, that bounce. Let's see the subsequent bounces. Subsequent bounces, I can't really catch anything because it's so quick. And they actually look rounder in the graph editor, but this one for sure needed to be a lot rounder. So when I zoom in a bit, remember that in the graph editor, you guys, you do need to scale and zoom quite a bit to make the graph make any sense. This one needed, okay. So the tangent handle is going in the right direction. They're going almost straight up and down, but it still doesn't look right. And it's because these weren't scaled. And he's got weighted tangents, so he could have done it too, but for some reason just didn't. Maybe just forgot to do that. So we need this to be a lot rounder to feel more like a bounce. Probably about there is going to be appropriate. And I would even say the vertical alignment of these handles might be too far. It might be too vertical. This one looks like he was really trying to round that out but couldn't. And so it came all the way over here. And for some reason they're unified handles again. So I'm going to break them and then grab this one and move it a little bit further out. But because I can scale them, I'd also move it a little bit up, something in like this direction, more approximating the actual direction that the ball might be moving in. Let's look at the first drop also. Having trouble framing it. Let me just full screen that. Yeah, a little less round than I think it should be. A bit more like this would probably make sense. The next ones, they're so small and fast that we don't really get to see whether or not they're shaped right. That one looks great down there. This one probably could have been rounder, but it's so quick that we have trouble catching it. And you can see the amount of height that it's getting, about 2.5 units, is very, very tiny. So it's not going to affect the animations much. Let's watch that one now and see. Yeah, that already feels much better. The spinning of the ball is not synchronized with the movement of the ball. So that's the second thing that stood out to me, is that as we get into this latter half where it's actually making contact with the ground, it's sliding like ice skating over the ground, and then it's spinning far too much as we come to the stop. So for this, the translate X graph shows coming to a halt. We've only got 2 keys, so we got one at the start and one at the end. That means spin should only have 2 keys, and it should do the same thing if we're going to synchronize it. So here's spin, rotate Z, and it doesn't. It's actually got 3, and this one is almost flat. It actually looks like it's slightly not flat for some reason. If you want something to come to a stop, just hit this button. That's it. And then this key is the thing that's making it not synchronized. This one messed up the way that it interpreted. Even if they're on the exact same frame, which it looks like they are, or maybe not quite. Well, we'll assume they are. Even if they are, this is making it not slow down the entire way. So we've got to get rid of that. And now you see this big slowdown. That's going to make it feel a lot better. So let's move this out of the way slightly. There we go. Now I do think it's still ice skating a little bit over here. Let's pause it and take a look. So I'm looking at the stripes in the ball. This is the reason the ball has the stripes, is to make that more obvious, and the grid lines on the ground. And see there, it looks like it's not spinning enough for its motion. So we've got 2 options. We could start it at a greater negative value, or I guess this is positive value in this case, or we could make this spin more before it comes to a stop. In either case, we don't change the tangents, we just move the key further away in value from the other key, like this. So this means that more change has taken place from those 2 keys, and then we can either scrub the timeline to see, does this synchronize with the grid, or we can play it to try to see if it synchronizes with the grid. It's pretty close now. It might not be perfect, but it feels a little bit better. So you just needed a little bit greater value. Just to prove that this really will work, I'm going to move that back, and then instead move this one upward. That just means that the place that it starts rotating from is further away from the endpoint. It should have the exact same effect. Greater amount of rotation. Okay. And then again, as I mentioned to an earlier student, if you're going to have something roll to a halt, usually it needs to go a little bit past and rock back again to really lose all of that momentum. Because whatever stopped it is going to be some imperfection in the ground or something like that. And so it's sort of like rocking to a halt. Okay. Overall, pretty good. I actually do see squash and stretch in this one, so I want to take a look at that as it falls for this first time. There it is. Okay. I got to get this graph out of the way. I have 2 monitors. I always just put it on the second monitor. I don't know what to do with myself when I'm trying to show everything on one shared monitor. Okay. So we've got maximum stretch, squash, there it is, and okay, so right there, that's a little bit weird. It is slowly unsquashing. Here's squash, still squashed, back to normal, now stretched. That's too far apart. You got to move that keyframe to be the very next neighbor. So it should be stretch, squash, stretch, and then return to normal. Okay? And it's pretty weird in the graph editor, but this shape is the right one. So I recognize that as being a good squash stretch pattern. I don't know what's going on with the other one. It seems to just be stretching and then returning to 0. And so something weird is happening there, but this is the correct pattern if you want to add squash and stretch to your bounces. Okay. Cool. So other than that, looks pretty good. All right. Let's check out the next. Gunter. Let's take a look. All right. Uh-oh. Okay, that was pretty weird. Gunter, did you not use video reference? Hello? You still here? Gunter?
Oh, that's the wrong one. That's the mistake one.
Okay. Can you drop the other
I
one?
I already put in the correct one
Okay.
in the drive.
I'll download it right now. Um, the only file I've got up there says February 26th. Are you sure it's in the right homework folder? Oh, I'm sorry. I see the other one. Let's see. Which one did I grab? I grabbed ball rig. This one's GAM6B. Okay, let me download that. All right.
I am very
GAM6B.
sorry.
No, it's okay. If that was in there, I mean, it says it was in there February 26th, so I might have just overlooked it. All right, let's try this one.
Oh, no. I just put it in today.
Oh, okay.
The correct one.
Okay. Cool. Yeah, that looks a lot more like a real ball. Right on. Okay, let's momentarily turn off the NURBS curve so we can just watch the ball. Okay. Slightly weird at the end there. The dribbling is just kind of violent. I think you're trying to diminish it down to dribbling and rolling, but it's just moving too far. And I think that's where the graph editor can help to get those tiny, tiny little bounces that are hard to position in Maya. Other than that, most of the principles look like they're observed correctly. I'm having trouble identifying the kind of ball, but I think that if we get rid of the dribbling thing, it might be a little bit more obvious. So let's take a look real quick. So it looks like you're using the controllers correctly.
It was the first ball, but I accidentally made it a little too far, so I scrunched it down a bit.
Okay.
So it might. I meant went too far, and then so I used the graph editor to make it go exactly where it's supposed to.
Well, that's what I'm about to do too. We just got to focus on the right information. Let me ask you really quick about why there's keyframes on every single frame. Is that how fast it was happening in the reference you were watching?
That's the thing. Like I said, at first it was like this one. It was a little farther, so I shortened it, and I guess it kind of.
You mean time or space? Like how far it went or how long it took?
Length.
So how far it went?
Or I.
So there's two dimensions, right? There's time. Did you make things faster or slower? And there's space. Did you make it not go as far away or closer?
I think I did space.
Okay, that one's fine. That normally is something safe to edit. Timing is dangerous to edit until you have a more intuitive sense of it.
I mean, that's what I was going for. I was trying to shorten the length, not the time, but the length of it went. And
yeah, that's fine.
I think.
What I was referring to is the fact that there's a keyframe on just about every frame.
Oh, yeah.
It's really quick. Is that what was happening in the video reference you were looking at?
Yeah.
Okay.
There was you had the chart, and I was following your chart.
My chart? You mean like when I did an analysis of the blue ball?
Yeah.
Oh, I want you to make your own chart. Like I was doing that to demonstrate how to do it. But also, when I animated it, I didn't have keyframes on every frame except for a very, very brief period. You've got a lot more than I marked down. So,
I do?
Yeah, you do.
Oh, wait, I think those are those frames are from the, when I did the stretching.
It is. Oh, okay. All right. That makes sense.
That's where all those things come from.
Yeah.
Yes, that's all the frames.
Okay, here's what I'll say about that. Once you get down...
a little wild with that because I wanted to make a cool effect, kind of a...
Well, it's cool, but I don't think you need it unless the ball is like Jello. If the ball is Jello and we get down to this little tiny amount of bounce and it's still squashing and stretching, it's very, very soft. It's like silicone or something.
Oh, I guess then I did it wrong then because I was just so focused on doing this thing on every single one that my idea of stretching it to this, that, this, I got to.
Well, I won't say it's wrong. I'll say that it's an odd choice that I don't think is helping it.
Yeah, I was too greedy.
So what we can do, though, is we can just delete that much. And then there's no more squash and stretch. So it does it on these big bounces where it would be visible, and now it's just going to hold its shape.
Okay.
So it's easy to correct, or we can start scaling it further down. So I could take these and move the apexes and the bottoms closer together so that the squash and stretch amount is very, very small. And that way it comes to an end which is a lot more smooth and natural. So actually there's a lot of keys in here that maybe you don't need quite that many. But something like that, now the effect is still there, but it's diminished.
Actually, some of the frames are not just the squishing, but also the rotation spin?
Well, in this graph, no, they're not. In this graph, they're all squash and stretch. But if what you're saying is you were setting a different value and it happened to make a key here, that's when you need to start using key selected, right click, key selected, instead of just hitting the S key or key all.
I wasn't doing key all.
Were you hitting the S key?
The S key.
Okay, the S key is key all.
I mean, not S. I mean, I was doing the right click, key selected.
But if this keyframe then was only supposed to be on like rotation or height or something,
that actually is supposed to be squash. Never mind. I meant the one on the why there were so many red lines.
yeah, it's because of all of these keys that we don't need. Like what I'm saying is you don't need those keys or these ones at all.
Oh.
You just need the tops and bottoms. We don't need
Okay.
those. And in fact, it's going to actually animate a lot better without them, so long as your tangent handles are correct. And for the most part, it looks like they are correct. So now we've got far less information that's a lot easier to control. Did you see earlier when I was trying to move the maximum value, it changed the shape of the graph too much because there was this extra keyframe down here getting in the way of that.
Oh, okay.
See what I mean? So now it's easier to edit how big and small these bounces are because there's less in the way. That's what I was looking for. Okay, so don't add too many keys. Usually you just need extreme positions and breakdown positions. Breakdowns are a special thing that helps us to interpret how something gets from one place to another. But for the most part, the graph tangent handle should cover that for most stuff. Mostly though, I wasn't actually referring to the squash and stretch. I was referring to the translate Y being too large. So here's the graph that you got. And what I noticed as this thing animates is that it's moving too great a distance up and down in these little bounces. When we view the graph, it looks like those bounces are really, really small because I just framed all. I just hit F. But if we start to scale this down to an appropriate size, we can see these are actually pretty big as we get down to this last bit. So big that this is 1 unit in the air. That's an entire width of the ball. If we're dribbling to a stop, the ball really should not be getting over like half a unit, quarter of a unit, something like this.
Oh.
So I'm going to go something like this. And I'm just kind of taking a guess of what's going to feel better. Something like about here.
That's what you meant. I thought you meant the other thing.
So I'm going to make all those flat and all of these bottom ones sharp again because the tangent handles are just kind of getting out of control. And we won't even mess with the arcs for the moment. I messed up the arcs, but they should be fine. So now we're getting much, much smaller, approaching 0. Let's see how that feels. It's still very quick, but at least it feels like it's losing enough energy. We might even have to go further than that. Let's see. I think with the amount of space that you're covering, I need to scale this entire graph down a bit. So you were at 20. I'm going to bring it down to half the original height, so 10.
Yeah, I think I didn't do that. All I did was did the other way around, just made that without doing that.
Oh, the side to side length instead of the vertical also?
Yeah.
I see. Okay. Yeah. So it was so much happening in such a short frame of time that it felt very violent and sudden. Now it feels a bit more natural. You can change the lengths of things, how long things take, how far they go, but you got to be careful because this ball has a size compared to the distance it's traveling. And if you change that too much, then it ends up being really, really strange or different. So just be cautious about that.
Yeah, I should have realized I should have also done not just the length, but also the height.
The last thing I'm noticing is that the spin is, I think, stopping at a different frame than the movement. Let me see, 106. 106. No, they're stopping on the same frame. So what's happening? Okay. Your movement is not coming to a complete stop, but your spin, I think, is coming to a complete stop. Yeah. And so they're not quite synced up at the end here. Did you want us to observe this ball rolling to a halt, or did you just want it to be off screen?
I was doing off screen.
Okay, let me see how it plays. In that case, it plays fine. But it would be nice to just realize that those things are different. If it's just continuing, like that one, like mine was, then we take the spin value and we also just make sure that this tangent handle is at a certain angle, not completely flat, just still kind of angling down towards the end.
Okay.
Now they're going to synchronize right up to the moment they halt. Although it won't look like a natural stop, they'll just both stop at the same moment, at the same speed. But we can treat it like this. Okay, cool. Any questions or problems?
Just thank you for the feedback,
No problem.
and made me realize I forgot to do the height.
That's cool. You can always get it in revision. We got the revision folder up there. Just drop them in there. All right, thank you. Let's see. We've got Paul. Let's see where this is. Oop, there it is. Okay. Ooh, some weird squashing and stretching happening. Trying to ignore that for a moment to just look at the ball as it moves across the screen. It looks like it really loses all its steam right at the end there. I'm going to pretend like we're not supposed to see that, like it's going off screen, since I'd mentioned that in lecture and a lot of people did it. Probably means for us to view it something like this. All right, let's take a look at the controllers. We'll deal with the squash and stretch thing first because it's really obvious. So this amount of keys on squash and stretch is not enough. What we've got is no squash and stretch at the top and then squash at the bottom, and you can see what happens is it just flattens itself out like a pancake for the entire drop. So he's probably seen, like, if he's watching the video, what other people have done already is that this is the opposite value right before it hits. That's correct. This is the opposite value. So you can almost just take that number and just change the sign. If it was negative, make it positive. So there we go. And so it goes way up that way and then reverses. And then here, same thing. Just change the sign, essentially. And so you get this kind of hill with a big sharp dagger in the middle of it. Okay. With that said, the amount of squash and stretch is probably too much. It's very, very squash and stretchy for not enough speed happening in the animation. So I would reduce that quite a bit. The maximum value is 10. You're going like over halfway already. To do that, you can just grab the whole thing and scale towards 0. I would say let's not go beyond like 3 and see if that feels a bit more reasonable. Yeah. For the amount of distance and the speed, I think 3 is more than enough, maybe too much already. Last thing, if you're going to use the squash and stretch, we've got to angle this little halo to point in the correct direction. On the impacts, it's neutral, so this is correct. I'll just hit S. And then on the previous frame, it needs to angle itself towards the direction of travel, like that. And then you don't really have to worry about it up here at the top where the effect is minimal. Same thing right after, angle it in the direction of travel. This is a pretty subtle thing, but it makes the difference between it looking like it's jumping up and down of its own accord and it's traveling in the direction of its movement. Okay, and then it would return back up to normal at the top, wherever your keyframe happens to be. I don't actually know. I think it's here. Okay, back up to neutral again. All right, so be careful about that. The squash and stretch got very distracting because it's just kind of flattening itself like a pancake. Let's look at the other channels though. Okay, so for your bounces, They look generally correct. They're all sort of leaning to the right for some reason, though. And I think maybe the issue was you didn't break the tangent handles. Yeah, so they're unified. They're not supposed to be unified. That means you can only lean the V in one direction or other. Well, these ones are broken, but it's still doing it. This one's straight up and down. This one's leaning over to the right. Same thing over here. You might have thought for one reason or another that you didn't have to do both sides, but you do. This one's just as important as the opposite side. Bring them both towards the center so both sides end up being rounded. And of course, scale your graph so that you can see what's going on. But a little bit more round. And then by this point, we just about don't have to do it. And at this point, we don't anymore. So we can just ignore that part. But watch out for these kind of like torpedo shapes. Watch out for these asymmetric shapes that you get. Make sure that tops are actually flat. This one's angled a little bit, which means the highest point is somewhere over here instead of on your keyframe. So make sure the tops are actually flattened. And that should help quite a bit. I think this one's still a bit weird because it's so vertical compared to the other side. Okay, so that should have helped just a little bit on this graph. Translate looks basically fine. It's kind of maintaining the same speed for the entire animation right up until the very end, which would be weird. I don't know why that would happen. More realistically, it should slow down for the entire animation, even if just a little bit, which would be more like this. You can tell that you've moved this enough, by the way, when it passes the line. When it's on the line, that's consistent motion. Okay? If you go beyond the line, now it's going to be slowing down just a little bit. Okay? So let's take a look at that now that I made those couple little changes. Trying to frame this right so we can see everything. There we go. Okay, so that was a bit of an improvement. And I know I've done this on everybody's file so far, but I just wanted to demonstrate on yours as well. Same thing would be true of the rotation. You want to make sure it's doing the same thing as the motion and that it's synced up and not skating across the floor. But I think you're intending us to view that off screen, so we'll just treat it like that. All right, cool. Anybody got comments for Paul before I move on? Oh,
No, not really.
fair enough. All right, thank you, Paul. We've got Andrew. Let's see. Okay. Back this one up and play. There we go. That'll be about right. Okay. Couple strange things I see right off the bat. The red controller is leaned over to the side for some reason, but it doesn't actually appear to be animating, so it's not hurting the animation at all. Just want to check if that's true. Yeah. There's no keys set on the rotation. It's just leaned over for some reason. So I could zero that out, and it shouldn't change anything. I would change the direction of the squash and stretch handle. There might have been... okay, yeah. There was probably some confusion about when to move this controller and when to move the red one. So the answer is that the small yellow halo is only for squash and stretch direction, and the red one is for the global positioning of the entire ball. So you've rotated over the red one to get that position correct, I think, or to counter correct it or something, and it ended up making a little bit of a mess. So I'm going to just leave it alone, but just note that that's a bit weird. All right, so let me see. Next weird thing I saw, just like Gunter had, a bit too violent towards the latter half of the bounces. They're just covering too much distance for that amount of time, and then they're just done. And it's just very violent and sudden. As I'm looking up at the Translate Y graph, I'm seeing kind of a weird shape on that first drop. So let's take a look at that and see what caused it. Okay, so the tangent handle for the first drop, for some reason it's way over here, and this one is scaled very, very far. You got to make sure these things work together. This handle should be pointing relatively in the direction of travel, and that means that this one doesn't have to be scaled as far, and now we've got a more under control shape. Okay, so the two different handles, they always work together. You got it on all the other ones, just that first one got out of control for some reason. Okay, so there's that. That should help that first drop to behave a little bit more naturally. Then the height thing is just down to a bad return ratio. So for this first one, it looks to be no more than a fourth of the total distance. So that means this second one should be no more than a fourth of the total distance, like all the way down here. Then this one, same thing, no more than a fourth. And if you can't see, zoom in. Zoom all the way in. This final one, as tiny as you can make it. So now all the tangent handles are a little bit messed up because of that adjustment. But if I very quickly, let's just do clamped for all of them. These ones need to be sharp. And then if the handles are broken, which they are, perfect, I can just adjust them. Let's zoom way in because I can't see what I'm doing. And then this one doesn't really need to be, but let's just do that. Okay, so now, there we go. Now it's losing the appropriate amount of value each time. And that's just based on your decision. So it's not like I know what the right value is. I don't. I'm just using your first choice. And your first choice was to reduce it this much, right? From there to here. So I'm just repeating that. Repeat here, repeat there, and that's the pattern that we get. Okay. I don't see any squash and stretch. I thought there were keys on it. Yeah, there are keys. Oh, okay. So they only ever got to a maximum of 1 out of 10. So it's really subtle. It is there. There it is. I can see it now. Then squash and then nothing. And so for the rest of them, nothing. That's fair enough. I think that it was a little hard to spot because it is traveling pretty quick. I might crank that up a bit higher, and then you could have squash and stretch on the next one, but really you don't need it. I think you're correct in not animating that beyond that point. Might just exaggerate it a bit more here, especially the squash is half of the stretch, so it's even less. So it's really hard to spot. Here I've reduced it about up to 1, which is what you had in the first place, and then move the ball back down to the ground. At this point, it's just gone. I would probably have it disappear at this point instead. Key selected 0, so in the mid-flight, and then this one more time, having it stretch coming out of that fall. You could make it less, you could make it the same, but now we're diminishing it in a more natural way where it's stretching at the right moment, squashing at the right moments, a noticeable amount, probably if I take the controllers off. And then gone after that. Okay? So just a few adjustments here and there. I don't really know what kind of ball this is. It's losing a whole lot of energy when it drops, but it's rolling pretty appropriately and making a good amount of distance, so I'm not sure. So what loses its energy when it falls but doesn't lose its energy when it's rolling? Something stiffer. So maybe like a plastic wiffle ball that's hollow, that doesn't have a lot of bounce to it, or I don't know, a ball made of very stiff plastic. Yeah. I still think, like, watching this again and again, it does need a couple more dribbles to naturally end the amount of bounces, or even bigger loss of height. It just feels very sudden there. You know what? I think that maybe, oh, okay, there we go. There was something horizontally that was messing with me as I was watching this. That you've got a couple keys in here that you don't really need. Especially this first one is a bit odd because it's easing into motion and then resuming its normal travel. I would get rid of that. Just angle this one up, get rid of these two. Unless there's a reason to change the speed, like it hit a bump or something. Like that's probably going to be fine. Which you can do. You can change the speed if you need to for some reason, but I don't think you had a reason here. All right, cool. Anyone got comments for Andrew? Nope. All right, thank you. And that's it. That's everyone's file. I covered everyone, didn't I? Did I miss anybody's?
No way to know. They're not all here.
Well, you guys are here, so you're the only ones that count. Yeah, I'm taking one more look in the Google Drive folder, and I
Yeah,
don't see anything. Now, a number of you guys did provide some of your planning stuff, which I appreciate. Yang provided his right here. And so we can even see what I observed in the graph editor, which is that you had a very uniform linear progression down towards, stop it, down towards the rolling, which I felt had to be a little bit more of a scoop shape. So it's nice to provide that and a good way to plan things out. There were a couple more. Let me see. Where were they? Yeah, Elias had one. Okay. So that's how he planned out his. Foam ball. Oh, cool. And then Paul had one as well. And he had just his chart, which is fair. Remember this process because it's important when things are more inscrutable, when you don't already know how they work, when you don't have an estimate of how much time things should take. You really do need to make a plan each and every time for that. And that's especially relevant for our next assignment, which is animating the figures on your clock. I already have the assignment up on Canvas, and I have my own reference, which I acted out in front of camera. And I talk about in the first part of the lecture how it's very important to do that. And all serious animators do that. They shoot reference on video, analyze the reference, and then caricature from there. If you have to get reference of someone like an Olympian doing something really spectacular, then you can find footage of that. But if you can just act it out in front of a camera, it's better to do that. Everyone's phone actually has a really good camera on it, like better than you could have bought 10 years ago. And the frame rate's good too. So if you can shoot it on your phone and then like send it to yourself via an attachment in Google Drive or email or something, then that's great. Yeah, and acting class is useful for that too, because then you get to learn how to express yourself and control yourself through mime. Really, animation reference is more like mime. So trying to exaggerate where your body is and the timing of it. Although everything that you shoot on video will always be a little bit slower than the animation would dictate. And so keep that in mind. All right. Do you guys have any questions or problems?
all seems good to me.
Okay. Well, then
I'm
that's
good.
going to be the end of the review for today. On Friday, I'm actually going to demonstrate a concept that I wanted to cover, which is of what makes a key pose, what makes a breakdown pose, and what are they most useful for. And I was making today earlier, let me just grab it, I think it's on the desktop. Yeah, I was making today earlier this simple example of a pointing arm. Close all this. So that I can go from that pose, from this pose, to that pose and control it with the use of breakdown poses and what they're most useful for. Because there are infinite ways to go from here to there, but the most boring way is this one. It's terrible. And most of animation is not just making these poses, which are important. We need this pose. We need that pose. But it's finding an interesting way to go from here to there that is not only physically believable, but also shows character. So that's what I'm going to talk about on Friday for you guys. And I think it'll be a fun little demo where we can make this arm feel alive and feel more realistic and also give it some personality just with how we get from A to B. And we don't have to change the timing at all to do that. Okay?
Cool.
Cool. So that's what we'll do in our next one. Thank you guys very much.